Okay, the first time value money concept that we want to cover is future value. So what I'm looking at here is if I had a sum of money right now at present, which would be also known as the present value, what is the value of that money in a given time frame with a given growth rate? So for example, for this first example, let's say that I have $10,000 that I'm going to put into an account that yields 10% per year interest. Okay, for example. All right. And I want to know how much will it be worth in 15 years? Now, I can't just take 15 times 10% times 10,000 because interest will compound upon interest. So when that money grows, that interest rate will also, increase the amount of money based on prior interest earned in prior years. So I have this calculator, and if you want to build it with me, I'd recommend pausing this video and building this table here or something real similar. So the annual interest rate is going to be the amount that usually is given in a problem, but it's an amount for the annual compounds. If we're doing multiple compounds, I'll show you how to handle that. If we do, semi-annual compounds or monthly compounds or anything along those lines. The number of periods, so that one's a filled-in field. The number of periods in per number of periods is going to be the number of years times the number of compounds per year. So I'm going to enter that as a formula here. I'm going to take the number of years times number of compounds per year. I know right now it's 0. In this case, it's just an annual, so it compounds once per year, and I want to know what it'll be worth in 15 years. So my number of periods is 15. If it compounded twice a year, my number of periods would be 30. If it compounded, monthly, every 12 times a year, it'd be 180. So, but for now, we'll leave that at 1 for the compounds per year. My interest rate, I got my annual interest rate, but I want to know my interest rate per period. Since this is only once per year, it's going to be 10%. But if it were multiple times a year, I would take the interest rate and divide it by the number of times that it compounds on an annual basis. So I'm going to write that as a formula here too. I'm going to take 10% divided by the number of compounds per year. So in this case, it's going to be 10%. But again, if it were semi-annual, it would be 5%. If it was compounded twice a year, if it was compounded monthly, it would be 0.83 repeating decimal percent would be my interest rate per period. Okay, the $10,000 is the money that I'm putting in right now. So that is $10,000 is my present value. I'm going to look for my future value, so I write a formula in there. Payment, we're not really going to use on this one. I put it in there because it is a variable in the formula. But a payment would be if I was, in this example, would be if I was putting money into this account regularly as well. So let's say I changed this problem, and I'll do one of these in a later video, where I said, okay, I'm putting $10,000 in now, but I'm also going to put in $500 a year for the next 15 years. That would be a payment. So a payment represents some form of annuity, either cash flow or inflow or outflow of a regular amount at regular intervals. So in this case, since I just have a single amount, payment's going to be 0. And then type represents whether or not the payment is made at the beginning of the period or at the end of the period. So we'll plug in a 1 there for now, and you'll see what that means here in just a second. So now for the kind of the meat of this, how do I build my future value function from all this information? So I'm going to type equals FV, open parenthesis. Now, that might be hard to see. You can also click the F of X button up here to insert function, and it gives a little better detail here, and also defines kind of what each thing is. It even tells you about dividing the interest rates for the number of periods. So this rate number wants to know the interest rate per period, not the annual rate, but the interest rate per period. Now, I'm going to go change this back to once per year here in a second. But for now, I'm going to reference that cell because that's the cell that I want it to be, the interest rate per period. Number of periods, I'm going to reference my N per cell right here. Payment, I know it's 0, but I'm going to reference my payment cell here. Present value, That's my $10,000. And then type, it says here, the timing of the payment at the beginning of the period is a 1, or payment at the end of the period is a 0. So if I'm putting this in on January 1st, the beginning of the year, then I'm going to want to put a 1 there, which is what I'm doing here. I didn't put a date up here, but it's the beginning of the year. If I was going to put it in on December 31st, the end of the year, then I would put a 0 there. So that type is just for beginning or end of the period of time. So, and it always comes out the opposite direction, because the assumption is that one of these is a cash inflow and one of these is a cash outflow. So if I had $10,000 that I put into a bank account and it yielded 10% per year, and if it only compounded once per year, notice that changes the number, it would be $41,772 in 15 years. Now I'm going to go back through and show, just for my own purposes here, and so you can see these that I'm highlighting in this are the ones that I don't want to change because they're all formulas, but I could change any of these to a different scenario. So let's change the scenario and say that I'm going to put $500 into a bank account, and the interest rate is compounded monthly, and the interest rate is, the annual interest rate is 8%. And I want to find the value after, let's do 25 years. Okay, so my annual interest rate is 8%. So I'll put 8% in here. Payments, I'm still not making regular payments. That's fine. I'm putting only $500 in the bank account. The type, I'm doing it, we'll do it at the beginning again. A number of years is 25 years. And compounds per year, this one is compounding monthly, so it is compounded 12 times per year. So there's the value. If I put $500 in a bank account and an interest rate of 8%, and it compounded monthly, the value, the future value of that is going to be $3,670.09. And that's how you calculate the future value in Excel.